All right, well, 3 minutes past the hour, it's usually about the time we get started. So let's go ahead and do that. Uh, Again, thanks everybody for joining us today. My name is Rob. I'm Director of Sales and Marketing here at Sniffer Robotics. So you've received an email or two or three from me leading up to this event. So again, thanks for your time today. If we want to roll into the agenda here, just talk through what we're going to cover in the next 45 minutes or less. So, brief introduction to Sniffer Robotics, who we are, talk a little bit about the market opportunity available for aerial methane detection, and then roll into technologies available to do that. And then from there, we'll talk about Sniffer's technology and how it can be applied, and move into our newly introduced Methane Analysis Partner Program, or MAP. And the intention of MAP is to take our technology and partner with environmental engineers who are out doing, various methane monitoring, so you can deploy that technology on your own. And then we'll wrap up with a quick Q&A. And again, encourage everybody. So you are muted now, but if you need something, raise your hand or shoot me a chat, or if you have any questions, pop them into the Q&A. So without further ado, I will pass it over to the CEO of Sniffer Robotics, Bill Tennant.
Hello, everybody. I'm Bill Tennant. I'm the CEO of Sniffer Robotics. And a brief introduction on myself. I've been doing landfill gas for about 18 years. Prior to that, I was an engineer officer in the Army for 20 years. And so now we are focused on methane intelligence. I say methane intelligence because methane monitoring means you go find few points and you report them. We do a lot more than that, and we're really focusing on a lot more than that. So a quick little bit about methane and Sniffer Robotics. First of all, we are approved by the US EPA for quarterly surface emissions monitoring at landfills in the United States. And we are also approved. We need to put a little icon up here for Environment Canada as well there, Rob. We're also approved in Canada as well for their upcoming regulations, which will start, I believe, at the beginning of 2027. You can see we have partners, all over the place now. We've got partners working up in Canada. We've got partners assisting us with some projects on the West Coast. All the red pins are our locations. We have active partners in South America, Argentina right now, and I'm actually going to be starting work in Brazil at the end of this month. And we have active partners flying for us in France and the EU. So for a little company, we're spreading our wings a little bit. I guess a joke intended there, and getting out there. We partner also with Project Canary. They take all of our emissions data and our wind data from the drone and do emissions rate quantification, which we'll talk about. And then across the bottom is just a laundry list. It's not even nearly a full list, obviously, but a list of some of the types of companies we work with. We work with the large waste companies, a lot of the large renewable energy companies, with the consulting engineers, and also counties and local municipalities to provide emission services. So when we talk about why MAP is good, especially for landfill people, first of all, we do more than just landfills. We were designed to operate in landfills, but our technology works at other places. So when we look at just the monitoring market for landfill gas and biogas and landfills, it's about a $600 million estimated market. Globally, that monitoring market is like $2 billion or more, right? So, the MAP program allows us to get our technology in other people's hands, but if you're focused on landfills, it could potentially also open up other avenues, doing work at anaerobic digesters, doing work on covered lagoons and things like that, where it gives you more opportunities for revenue that you might currently have just doing strictly landfill work. So that's one of the things I wanted to highlight with this slide. And we have solutions for all these different things. And we're also partnering now with a company called Perspectum and their sister company, Delmar, who are in the oil and gas industry. And we're starting to use our technology with them in the oil and gas industry as well. I didn't put that on here because it's not fully developed, but that's coming soon. So sure, it's a landfill technology, but guess what? It's really good at a lot of other spaces that allow you to generate revenue. So what happens? We've all heard about Carbon Mapper, GHG-SAT, and all these other things that are out here. But they're great in that they're like a canary in the coal mine. They'll say, hey, you got a problem, but they don't tell you what to do. So they're just saying, hey, there's a problem. What we provide is there's a problem, here's the fix. So, and not just, here's where the emissions are. Here's where the emissions are. Here's what's leaking. Here's what possibly is going on. So in this particular slide panel, the first one was the satellite hit. The second one, we flew the site the same week and got that emissions interpolator map. And then we went out and manually verified in the field, found individual points on the ground with flags, GPS coordinates, and pictures of where the leaks were coming from so that the site could go out and fix them. That's the difference between emissions leak locations and actionable information. You can physically go out in the ground and fix it. Various technologies out there. This is focused on the landfill industry right now. There's only 2 technologies right now you can use for compliance monitoring. One is method 21, a guy walking. The other one is OTM 51, which is the sniffer drone, a method that was developed. There's other emissions monitoring capabilities out there. The sniffer drone is somewhat unique in that we can do localization of leaks, but also we can do emissions rate quantification. They're starting to work with TDLAS lasers to get some quantification as well, but it's not fully developed. The TDLAS lasers can do localization, but they do their measurements in parts per million meter, not in parts per million. Then you have aircrafts and satellites that are out there getting the big picture, fixed sensors. So there's a lot of different things going on in the emissions technology world. People ask me, what do you think the best technology is? And the reality is, it's a mixture of technologies because not everything is perfect, right? We're really good at localization. We're really good at quantification, but we're a snapshot in time. We're not being there at night. We're not being there 24 hours, not being there and changing whatever, because we might be there once a quarter. So, or once a month. So it's a snapshot in time. Fixed sensors give you a long-term look. They're not very accurate as far as location. So if you mix fixed sensors with us, fixed sensors are watching, all of a sudden they see a spike in emissions. You bring the localization team out, we fly it and say exactly what changed, and they go and fix it. So you may end up a combination of technologies. We actually had somebody say, hey, I think I'm just going to develop my own. I don't want to, wait for you to, or to pay for you to do this. Well, that's fine. You can do that. The OTM 51 right now is specific to Sniffer Robotics, but it does say that anyone that puts together a data package and submits it to the APA can be approved to do that. So yes, it is feasible for someone else to do OTM 51 method. But the problem is we spent 9 years and we've spent millions of dollars developing the system. We have advanced sensors. We've got a lot of algorithms for the flight controls, which is really the thing that no one thinks about. And a bunch of other things that we've done to develop this hardware. And then we've already got the US EPA approval and we're already out proven in the market. So you've got a fully developed commercial platform that's ready to use today. It's approved by the EPA. It's got support for worldwide use. We're already flying, I think we flew like in 7 countries last year. So it's a fully developed project. So you're getting your hands on some of the best technology available without having to do the 8 years of development to be able to do something in the field. All right, so let's just talk about how good is this thing? We've done a lot of testing, both field testing and also scientific testing. But the most recent test, which was sponsored by the industry and EREF, was the Petrolia study done by St. Francis Xavier University in Canada. We participated in that study, and we were rated as the best technology out there. That included fixed sensors and other technologies for localization. They said we had 1 false positive and 2 false negatives out of the 30 or so things we were supposed to find. Now, okay, that's pretty darn good. And if you look at the other technologies, that we are the best. Now, I will tell you that's going to get improved, because one of the false positives that they charged us with, or false negatives that they charged us with, was a site we didn't even monitor. They had a mechanical issue and shut one of our tests down early, and we didn't get to that location, and they charged us for not finding it. So that's going to be edited a little bit. So really, our orange bar here is going to be cut down by half. We'll have 1 false positive, 1 false negative, and about 90% accuracy on unknown, finding stuff in the field. So that's pretty darn good. We also were ranked, I think, the second best technology of all the technologies, including, permanent sensors and everything else, for quantification. So you're getting a field tested, scientific tested, calibrated system that is proven to be one of the best in the industry right now. All right, so let's talk about, that we had that, we spent a lot of time developing, and what has changed. So from the first, most of our life, we were operating in the Gen 1 platform, which is a really good system, and it worked very well, and it allowed us to get the EPA approval. It allowed us to develop all of our ConOps. It allowed us to develop all of our software and reporting packages, but it was a little bit unwieldy. I couldn't just hand it to a third party and have them fly it. The pilots took a lot of training, like up to a month to train on it. And it was on an M600, which is a really large platform. And due to the weight of it, we got about 15 minutes of battery life. So in January of last year, we fielded the Gen 2 platform, which is what we're talking about now. It's dropped the weight down to about 2.5 pounds. So it fits on a very common commercially available 350. So we doubled the battery life. Also, the sensor on this is capable of measuring down to 250 parts per billion. All the other sensors being used for monitoring right now for localization are in the parts per million range. And our previous edition was in the parts per million. So it's also very sensitive and very accurate. So it's a great improvement. It's very easy and intuitive to learn. Typically, an experienced pilot 1 day in the field in training can learn how to do the basics and be able to fly, a couple times in the field, and they're ready to roll. So it's very commercially friendly and very easy to support. This is it flying in the field. We like to joke that we are the stupidest drone company on the planet, because we're flying a drone, which is high tech, but then we're dragging the nozzle on the ground. But there's a reason for that. And the main reason is we don't like math. Math is hard, and math adds error. So instead of using modeling to determine where the leaks are coming from, we are doing direct ground measurements. We're measuring gas at the ground, pumping it up to the drone. We're collecting the gas at the source on the ground, pumping it up the drone and analyzing that, and then tracking where all that is. So it eliminates a lot of error, because you're not doing math to calculate where things are. The only 2 places we do any algorithms or math at all is we get wind and speed and direction from the drone, and that requires an algorithm to do. And in the emissions rate quantification, it's an emissions model. So we've eliminated a lot of error and helped our precision by eliminating models. Okay. The other thing that's great about this is that's how we got the EPA approval, because we are literally doing method 21 almost exactly the same as you would do it, except we're flying it. So we're doing it 4 times faster. So let's talk about data collection. The Sniffer drone is a very good data collection tool. So the way it works is you saw it flying, it's going to fly that serpentine pattern. We can adjust the spacing, either 30 meters, 15 meters, or 7.5 meters, depending on what we're doing. That's all programmable. As the drone flies, it's flying at 7.5 miles an hour, taking 2 readings a second. So we're getting a data point about 4 feet apart across the entire surface of the landfill. And that spacing between data points is very consistent, and the spacing between paths is very consistent because it's controlled by GPS. As the pilot's coming back, he hits send on the controller. The data gets sent in an encrypted file from the drone through the Wi-Fi hotspot, the AWS and into ArcGIS. And as soon as it hits our platform, these yellow circles show up. So if you're in the field and the pilot sends the data, if you're holding your phone, you hit refresh on your app, these circles appear instantaneously. You could literally navigate with your phone to the center of that circle and find the location right then. So it gives you near instantaneous ability to fix problems. If you're doing it for compliance, a technician will go to the center of that circle, find the exact point, put a flag on the ground, take a picture, hit send. That gets uploaded in the system. And again, near instantaneous for the operators to go out there and fix it. This is just kind of showing you what it looks like. Very precise pre-chrome flight plans. We also have a lot of QA in that we put geospatial buffers around every point so that we can identify if there's gaps in our coverage. And we have our GIS technicians on standby while you're flying, talking back and forth to you in the field as part of the map program so that they can identify that, yes, your data is good, or, oh no, you missed a spot, you need to go check this area. So there's active quality control while you're in the field with our technicians to make sure that everything's good to go. So let's kind of switch base here a little bit and talk about compliance. Right now, the main method being used out there is method 21. Not very efficient for a lot of reasons and not very accurate. And it provides you with leak locations. It doesn't provide you with any type of intelligence. Speaking of intelligence, this is an EPA inspector out walking sim. And you can see not really following the method. And yeah, that's why we love the EPA inspectors. Okay. So why do OTM 51 for your clients instead of walking? The first thing for your people is just operational risk. There's all the hazards out there that you're avoiding by being able to do this work with a drone. There's also a lot of places now, California, for example, Oregon, where they used to exempt the steep slopes because of safety risks, but now they're getting rid of that exemption. So now you have to walk those slopes. Well, now you don't have to worry about that because you can fly them, and you don't have to worry about your guys on those slopes. Next thing is just operational efficiency. If you're on one of the West Coast blue states where you have to do it at 25-foot spacing on a 300-acre landfill, that's a lot of walking, and it's very labor intensive and very costly. We can do the work 4 times, at least twice as fast, but in those tight spacings, probably 3 times, 4 times. We can cut your time in the field and cost significantly, which makes your offerings to your clients, first of all, they're going to get a lot better products. Second of all, they're going to get it sooner. And because you have those efficiencies, you can probably be at least exactly the same price as walking or even a little bit cheaper. So it's very attractive to your clients. So you're giving them better stuff, more profitable for you because you're less time in the field, and it's a better product. And then the last thing is, we already kind of talked about, is the data is really good. The information you get is very good, very consistent spacing between points. There's lots of quality control and a lot of automation so that you're getting near instantaneous results from your work. We also, to support you with MAP, we've developed all the required reports that are required by OTM 51. You've got your data tables here that show every exceedance point. You can see on here where it says Sniffer drone parts per million 325, manual verified 700. Anywhere there's 200 parts per million, a field technician manually verifies that. So it's not the drone determining whether you're out of compliance. It is a person on the ground that gives a little bit of a person in the loop to make sure that it is actually out of compliance. And we do have locations that show up in the drone as being possibly out of compliance, but when you manually verify them, there's not an exceedance there because it was catching the plume from another exceedance, a little bit further away. So having that manual verification is very critical for, first of all, for compliance, but also, for confidence that we aren't just, that there's actually a person actually saw it. All right, so we've talked about the technology and market. We've talked a little bit about compliance. So let's just talk a little bit about what you get, not just that, information, but intelligence. Because to me, it's great to get information, but intelligence allows a decision maker to make a decision. They get the accurate intelligence. They can act on the intelligence to get the result they want. So when you're doing manual SEM, you're doing it at 30 meters, so inconsistent data. When you're doing it with a drone, you can adjust the spacing depending on what we're doing, and you can identify a lot more information. And then you can use that data to do a lot more stuff that you can't really do very well with manual SEM paths. Uh, the key here is if you, for example, if you were doing compliance, maybe you 4 weeks prior to doing your compliance event, you do a drone survey. And you do it at, we always do our surveys at 15 meters. So if you were doing a 30-meter SEM, you're going to do it at 15 meters. You're going to find more stuff. You fix it before they come out. And then we can also use that data for a lot of other things. Here's just a sampling of some of the products we can produce for clients and for our partners. You're always going to get that leak location map on the left. That shows you, where your 200 parts per million leaks were, where your 500 parts per million leaks were, and the grid coordinates and all that information associated with that. We almost always, not in studies, but not in compliance, we don't provide the interpolated maps for compliance normally because compliance reports are go, no go. We don't want to give the regulators any additional information. But however, if we're already flying a SEM for a client, we can produce this map for them for their own intelligence outside of the compliance report. And if we're doing quarterly surveys, we can also provide them with change maps that show the difference between surveys. And at the end of the year, we can do a change map that shows here's an area that was consistently there all quarter. And then we can go one step further and say, here's an area that's been consistently there all quarter, but it's been getting worse. So those are actual areas that you need to address based off the intelligence you got from the platform. And then we can also do we can do quantification through Project Canary, where we can tell you how many cubic feet per minute or kilograms per hour are emitting from the surface. That's very valuable because, first of all, if you have an RNG plant, it gives you an idea of how much more potential gas you can collect. But if you're doing a lot of work and if you're doing a lot of mitigation, it also can show you a trend of declining emissions based off the work you're doing. So here's some examples of how intelligence versus data, okay? We were hired by a client to fly their site. They were getting ready to install $750,000 of a collection system in the north area. Now you can see there was a little gas there. They could have gotten some improvement for their plant, but they were about 400 SCFM short of having enough gas to make the project viable. After our flight, we identified, there's not a lot you could put there, but there's not a lot. There's a whole bunch of gas down in the south area. So they rethought their plan and adjusted their plan to collect gas in the south because that's where the gas was. That's actionable information, but that's also intelligence. You're giving the leader a decision point. You can continue on with your plan here and get the 100 SCFM-ish from the north area, or you can adjust your plan completely because you're going to put a different type of collection down here, but have a better chance to collect a lot more gas. So they took the action of going to the south where they saw the gas. Here's another case study which kind of brings everything all together. We talk about doing an emission study. We talk about emission gas analytics, and we talk about data trending to give you intelligence and actionable information. In this particular site, we did a series of flights over a period of 6 months, but we also continued semi-annually after that. In January was our baseline flight where we identified all of the emission sources for them. They provided us with their well field monitoring data, and we looked at all the well field parameters. So they were able to look at their emissions, look at the well field, and where well field performance issues were causing emissions, and then use that intelligence to adjust their engineering plan. They, fixed all the slopes where there was leaks. They looked at, headers that were bad. They relocated potential wells based off where the emissions were and used that information to adjust their plan to make a new plan. February was construction month. March, they completed their construction, and you can see, okay, there's only a little spot here left, right? Well, that was the active work phase area. It was the active work phase area was moving back and forth across this area right here. So over the next 3 months, as they were moving the work phase, they were installing horizontal collectors So in June, now they are collecting almost all the gas. And you can see this through the data, and you can see this through their results. Here, data trending just straight emissions rate, SCFM, going down. This was average parts per million across the surface, going down. Total leak locations, trending down. That just gives you analytics to show that what you're doing is working. Of course, the big one is over here. They went from 1,500 SCFM to 2,000 SCFM. And if you do the fuzzy, bean counter math, that's about $1 million to $1.5 million a year in additional revenue based on that gas. So not just giving your clients, here's where your leaks are, here's a pretty map, a roadmap to collect that gas and get it into the pipeline so they can make money. All right, so we kind of talked about why I think methane intelligence is more important about our technology and how we do that. But let's actually talk about how we work together so we can offer that to your clients. It's pretty basic, simple forward. So we have a partner. We will come out ideally and do a technology demo. We like to do that within reason. If you have multiple clients that might be interested, we find a central location. We'll come out for a day. We'll fly a 30 or 40 acre part of the landfill. We can instantaneously show them the data. We can show them we can go out physically manually verify so they can say, yeah, they said it was here. I went out there, I found the actual point. We can go back into the conference room, review all the data, throw it up in ArcGIS so they can really see how everything works. And we'll have lunch and chit chat and all that kind of stuff. So once you're convinced, yeah, this is what I want to do, then we work on we negotiate the contract, and then you start flying. We provide you with a payload. We provide you with all the associated information. We typically provide 2 software subscriptions, 1 manager and 1 field subscription, and training, right? And then after that, once you start flying, the data comes to us. We process the data, provide you the reports, and then you compile that for your clients and get it to them. That's basically how it works. Okay. So why is this a good thing? Well, why is it good for us? Our thing is we have great technology. We're approved by the EPA for compliance across the world. Compliance is a heavy lift. I don't have 500 field technicians to go out and do all the checks and rechecks. So if I get partners where we're flying, or they're flying, and we're just doing data, and they're doing the flying and the rechecking and all that, I can scale that way. And there's multiple ways we can do that. Allows us to focus our efforts on upgrading our technology, upgrading our reports, and providing better service to you guys, because we're not spending our time managing field technicians. And larger companies or field service companies, you're doing a lot of things at landfill. You're doing stormwater, groundwater, methane monitoring, welfare monitoring, gas construction, all these different things. And a lot of times when municipals want to put out their contracts a bid, they put it all out as a package. I want a gas contractor. Well, it's hard for me to bid just on SEM when they want everything else. But if you guys are bidding on it, and you can say, hey, not only are you going to get SEM, but you're going to get drone SEM with all these extra capabilities. Now it helps us. The client probably will like it. It might help you get the bid as well. We're getting a lot of requests now, especially with the changing regulations from municipals on how we can get on their sites. Why is it good for you? You're getting all this, you're getting all the software, all the hardware, all the technical support, and all the pre-developed project, documents and everything else as part of the service. You're getting all that. Additionally, if you have, we customize stuff. If you need custom reports or we're client needs certain things, we can do that. It also gives you the potential to get into other markets, get into the biogas market, get into, down the road, oil and gas, and all these other markets that will provide additional revenue. If you're a field services company, and I worked as a consultant for 5 years and had to do some, and my guys hated it. We were constantly getting guys with bad knees and bad backs and all those other things. You're reducing the workload on these guys per SEM. They don't have to do the serpentine path. That is the hardest part, right? You're getting them out of the field. They still have to do rechecks, and they still have to do manual verifications and penetrations, but those are a lot easier because you're just going point to point to point, and a lot of stuff you can ride a buggy to do. So you're really helping the retention and safety of your people. And I think we provide a differentiated service. I think when you look at what we do, we've been proven both scientifically and through operations that we are the best or near the best at what we do. And we are very good at developing the picture and using our technology to provide intelligence versus just localization and leak locations. So I think it's good for us, it's good for you, and I think it will be a good partnership. So just overall, just some highlights. We are the only US EPA approved method right now. Now, there may be some alternative methods approved in California under the LMR. Nothing, they'll have to be submitted for approval, and they're looking to approve some laser assists and everything else. But that will be state by state. But we're still the only thing approved across the United States. We're the only technology right now that does at source sampling. Everything else is done through the plume, which means you got math, which means there's error. We've been validated in multiple scientific studies. Petrolia, we work with Florida State with tracer correlation and everything else. And I think one of the cool things is we can localize and quantify in the same flight. We don't have to do a localization pass and then do it upwind, downwind, for quantification. It's all done at once. And I think we've already talked about, it's just really good work. It works really well. And there you go. Okay. So what I want to do now is transition over really quick, because I know some of you have already seen this, some of you may not have, just what it looks like in GIS real quick. I think I'll start with a really quick look at, okay, here's the landfill, obviously. So when the pilot is flying, he's going to develop all these points, right? The points are going to pop into the system. And if you click on a point, you're going to see that's the point number. There was like 28,500 points on this site. There's your methane quantity. It's got the lat long and some wind data associated with that. As soon as that hits ArcGIS, the peaks show up, and they look like that. Yellow peaks are 200 parts per million. Red peaks are 500 parts per million. So if you zoom in on a peak and click on it, you'll see 397 parts per million. So that's not out of compliance, but it's required to be verified. And there's a good chance, about a 90% chance, if I go to that location and check, I am going to find something over 500 parts per million. All right. So this is a non-compliant study that we did. So the next thing we're going to do is we are going to make that interpolated map, which looks like this. Other people call it a heat map. I call it an interpolated map. So if you click one thing I love about ArcGIS is you can play with layers and click stuff off and on. You can see, yeah, there's quite a bit of lineup between the peaks and that. But there's other locations where there's emissions that aren't above 200 parts per million. So if I wanted to say, okay, well, what's going on here? I can click on it. Click on it. There you go. And it was 192 parts per million. So that was just under the threshold that would get in a peak. But if you were an RNG company, you might want to address that to get that gas in the pipeline. So what it allows is for you to get really deep into the details, not just compliance points, not just points around 200 parts per million. I had a client, we were looking for stuff in the field, 50 parts per million and less. I mean, so you can really get some pretty high fidelity on collecting gas and reducing emissions. Let me turn the peaks off again, turn the points off. The other thing we can do is to help when you start wanting to get methane intelligence is to pull the gas well monitoring data in. So that's what this looks like. If I click on a well, you can see here's all the well information for that well, vacuum, gas quality, and everything. And then we can do all the well parameters. I'm not going to go into great detail because we are constrained on time and only time for questions. But temperature, there was no issues at temperature on this site. Balanced gas to O2 ratio, that means there's probably an air leak or some air intrusion at the well. You can see the orange ones here. There's some that are close to that 4-to-1 ratio. System versus static pressure, likelihood of water in the wells. When you get these, there's going to be the map, and then there's going to be a list of the top offenders. So you have a checklist of things you need to check. Do I need a pump? Do I need to do a water level reads? And then system vacuum, clear as day where the vacuum loss is. So this really allows you, and when you correlate that information, hold on, let me do that real quick. System vacuum, let me do it this way. wrong one. And with the interpolator map, you can see there was emissions in that area likely caused by the loss of vacuum. So you'll be able to look not just at, oh, there's emissions here. Here's the cause, fix the cause. All right, well, that's that one real quick. Let me go to another one. We talked about adjacent markets. Here's an anaerobic digester. It's the same basic concept. Where's the points? To point 12. Here's the points on that. You notice it looks a little different because these tend to have lower level readings. So we make the point size based off of how much methane is there. So if I click on this, you can see that one is actually 391 parts per million. But we do the same thing. Where we can reach, we'll manually check it. Where is that? Different verifications. And then if I click on one, you're going to get 3,000 parts per million. You're going to get a location and either a flag or a paint mark or something of where it's leaking. So you can get down to the level of giving a client a list of things that need to be fixed. One more thing I want to show you all for your clients as well is what I love about this is even though this is manual technology with the ArcGIS platform, we can be full service. So for digesters, we can do the digester, but we can also do the processing facility. So it's one-stop shopping. For a landfill, we can do the studies on the landfill, but we can also go into the plant and check the whole plant. So you're not just providing utility for the landfill, you're providing for the whole system. So this is what you get if you go to Google Earth or whatever. We go in and get better imagery so you can actually see what's going on. They provide us with the site plan overlay. We'll throw in GIS, we'll throw some labeling and make it pretty. When you get the leaks all checked, you can see them on where they are on the thing. And then if I click on one, again, you're going to get that pop-up. It's going to show you that many parts per million. It's going to say it's at the thread of membrane 2-61. And when you look, it's right there. And I really don't know how you can't fix it at this point, right? So that's kind of how you take just leak information through lots of different analytics and visualizations and tools and turn it into methane intelligence, which you can actually use as opposed to make decisions off of both in the engineering side, on the operations side, and in the plant in order to improve your performance and collect more gas and improve revenue. So there you go. So what are the next steps? You want to talk about next steps there,